Alright, hey guys, welcome to today's video. We're going to look at using similar triangles today to work on a couple of different aspects of finding measurements and finding side lengths and proving similarity. Okay, remember we talked about in class today, just because something looks similar, to the eye it may be similar. Remember the definition of similar, we'll talk about that in just a second, but remember the definition of congruent means we have something that is the same shape, same size, same angles, measurements, and same side lengths. So basically, you're looking at an identical copy. So like a cut and paste. If you're cutting and pasting something on Word, and usually what you have is, you usually have a copy. So what we're going to do today is we're going to use and find similar, but we're going to do it with triangles. We're going to use it to find proportions to prove the similarity in geometric figures. So instead of doing it visually, we're going to do it mathematically. We're also going to use the similar triangles to solve for missing side lengths. We're going to find side lengths that are missing, have a different variables, and we're going to use proportions to set that up and solve. And then finally, we're going to use similar triangles to determine indirect measurements. Remember we talked about indirect measurements, and we did some of that yesterday and today, to where it's some objects sometimes that you cannot measure from the ground, like a tall tree or a tall building or a light pole or a flag pole, or anything that's really too tall to measure. But we can use similar triangles and use matching data to look at that and hopefully figure out how to solve for that finding. Usually it's around height. Okay, so let's look at what we're talking about here. Remember, here's a definition of similar figures. These are shapes that have the same shape and the same angle measurements, but they are different sizes. And unlike congruent shapes, the side lengths on these are proportional to each other. They're not the same. They're going to be one's either bigger or shorter than the other one, okay, or longer or shorter, excuse me. Okay, so what we're going to do is we're going to use these similar triangles. We're going to set them up to prove similarity. All right, so the first one, let's kind of just do a couple sample problems. This kind of goes along. If you have your similar figure notes that we did in class, I'm going to follow the same format. I'm going to go with proving similarity, finding side lengths, and then indirect measurements. Okay, all right, so let's get started. Well, if I look first again here, we look here. This kind of helps you out. This right triangle. It looks like a right triangle, and in Unit 3, we're going to prove if this is a right triangle. Okay, but these two triangles look to be right triangles, and they do look similar. If you'll look, they have the same shape but different sizes, and all the angle measurements should be the same. Okay, so we can set up a proportion, but I'm going to set up a proportion between these two numbers up here and two numbers down here. All right, so it doesn't matter which two I choose. I just got to pick the two in the same spot. So remember what we talked about, kind of like setting the equal sign. I'm just going to pick two numbers. I'm going to pick 3 and 4. Well, if I pick 3, I make my ratio 3/4. There's different ways to do this, but remember, I try to keep my numbers together. I want to make this triangle proportionate to this one. All right, if I look right here, 3 is equal to the spot that's equal to on this one is side DE, which is 6, and 8 is on the bottom down here, which is the side BC up here. So my triangle has a bottom side measurement of 8. Well, to prove similarity right now, one thing we talked about this, you could actually do this. If I reduce this fraction, this was in lowest terms, right, simplest form. If I reduce this one will reduce to 3/4. So it's kind of a shortcut. 3/4 equals 3/4. Okay, and remember, I forgot to do this part. Remember, if we talk about this, if this comes out to be a true statement, then the triangles or the quadrilaterals, the rudder, whatever you're doing, they're similar. If you come out with a false statement, then they are not similar. Okay, so they will be different. They will look alike, but mathematically they will not be similar. All right, so if I reduce this to 3/4, then 3/4 equals 3/4, then right now we know these should be similar. But if you'll remember yesterday, what we want to do is we want to set it up and we want to cross multiply. So if I cross multiply 3 times 8, okay, when I cross multiply that, I should get 24. Oh, excuse me, let's get rid of that green because it is kind of hard to see. Okay, so 3 times 8 is 24. 6 times 4 is 24. Well, again, this is a true statement, so these two triangles are similar. All right, now look at these. These look similar. Okay, they're very, very close. Look at the difference in the numbers. Okay, so it doesn't matter which ones I set up. I'm still kind of go with, usually I go with the side over the bottom. It doesn't really matter. You can go bottom over side. It really doesn't, as long as you are consistent of how you set it up. If you set this one up, you've got to set this one up the same way. So if I set this up, if I set up 5/7, so the ratio of the top, I have JK over KL. which down here means I need mn over np. All right, so if I set that up, 5 and 6 are in the same place at the line, and 7 and 8 are at the same place. Well, right now I notice, even though, again, we just said this is 3 over 4, right now these are not similar. 5 over 7, 5/7 is not equal to 3/4, so these should not be similar. But we're going to do the same thing we just did. We're going to go ahead and set up our cross multiplication. Okay, so we're going to cross multiply. So 7 times 6 is 42, and 5 times 8 is 40. Well, this is a false statement. Okay, that's false. So these two are not similar. See how it works? Okay, just got to be careful with it. All right. So let's load this up just a little bit bigger where I can move it around. All right. So now maybe you can see it just a little bit bigger. Let's go 200. All right. So now this one is a little bit different. If you'll look, this triangle here has been manipulated. The bottom one, one of them has been manipulated. It's been turned. So what we got to do is get these triangles, and a lot of times you'll have a description up here saying TSR is similar to HGJ. Well, right now I don't have that, so we got to kind of look at it. Let's set this back up the way it goes. So what actually I'm going to do is I'm going to rotate this smaller triangle. I'm going to take G, I'm going to bring it down here, which is going to bring H up here, and it will bring J down here. So what I've got is G, H, and J. So I like to kind of get them back to where they at least look like similar triangles. Now we're facing the same direction, right? Well, 6 is on this side, and we have what? GJ is 5, and we have GH is 3, right? So now we can set that proportion up again, just like we did over here. Well, I can do anything I want to set up, any one of these three numbers I want to set up, and it's not going to matter as long as you set it up consistently, right? So what I'll do, let's go this side. Let's go this vertical side over this long diagonal side, okay? So we'll set it up 9 over 18. If we do that, we've got to set up 3 over 6. Well, some of you are jumping way ahead of me. I can hear some of you already. That one should be similar because this will reduce to 1/2. That will reduce to 1/2. So that means my two proportions are the same, so they are similar. All right? But we're going to do it, like I said, like we've been doing. And if you recognize that right off the bat, that is a test-taking strategy that will save you time. Okay? So we're going to cross multiply here. And if I go back up here, and if I look, 9 times 6 is 54. 18 times 3 is 54. So 54 equals, 54. So you have similar triangles. Okay? So that's a true statement. So true statements produce similar triangles. Okay? All right, see how it works? So just take your time, set that proportion up, and make sure that they are set up to where you can see this. So if you can't see that, flip it around, whatever you need to do to get it set up. All right? Let's go down here now. Let's find the missing side lengths. Okay? What we may do is just one or two of these. Well, there's only two here. Okay. All right, so here, this is what I was talking about. Normally you will see this. This says triangle ABC. Remember, this is our symbol for similar. It's similar to DEF. All right. So remember, what we're looking at is if I say this, angle A, right, is similar to angle D. So you can see already one of them has been, it's been like more like a reflection, right? All right, so angle B, we give that two angles. We'll call that. So B is similar to E, and then C and F. And remember what we talked about, that's going to be 3. And remember what we talked about here, even though we don't have angle measurements, remember these similar triangles, if they are similar, we'll have the same exact angle measurements, but we don't have the measurements, so we got to go the other way. All right, so in this triangle, what I needed, here's my unknown. I need to know what the side length is DF is. Well, I like to go ahead and set that proportion up. X over, now it doesn't matter if you use 15 or 18, I don't care. But I'm going to go ahead and use 18. Well, if I look, this is where it's kind of funny because sometimes you say, wait a minute, this is 24, and it may be because they're in the same spot. Well, let's make sure. If I'm trying to find DF, DF is the first and the last. Well, they match up, they correspond with AC. Well, now see here, this is what I'm talking about. Instead of 24, your answer is actually 28, right? All right, so then I have 18. 18 is on EF, which is the same as BC, which is the 24. Now you see how we set these up. Now you see how important these angle marks are. All right, so now when we cross multiply, just like we did up top, you have 24 times X is 24X, and then 18 times 28, and I'm going to use my calculator if I can find what I did with it. All right, so I have 18 times 28. should give me 504. So I have 24x is 504. All right, so remember, we're trying to isolate, we're trying to get this x completely by itself. Okay, that means we want to get rid of anything attached to it. Well, right here we have 24 attached to it. This says 24 times some number should give me 504. Well, the opposite of multiplication is division. So we're going to divide both sides by 24. This is going to get rid of the 24. So now all I have is x. Well, now we're going to take our calculator. 504 divided by 24 should give me 21, right? So what that 21 tells me is the side length DF is 21 units long. In this case, it's going to be feet, so it'll be 21 feet long because all of my units are in feet. Okay, so you see how it works? Just take your time and please use this. This is very important. It helps you set up these ratios. All right. If you look at this triangle, what happened here? Can you tell me what's going on here? What kind of transformations has occurred here? Well, if you look, number one, you know it should be a dilation, but they're facing a different direction. So what you actually have is a dilation and a reflection. Okay, so we've dilated and reflected one of the triangles. I don't know which way it went, I just know it did. Okay, because this is smaller, so you know it had to be dilated, or this is bigger, so it had to be dilated. All right, so let's set it up. Now we don't have our information, so we got to be careful here. But I do know that this does look like a right triangle, so we can kind of use that to help us set up. Well, if I'm looking here, the right triangle, if I go right triangle up the top, okay, what I'm looking for is this unknown side length here. Well, this is from the right triangle to the top on this side. So I'm going to set up x over 15, which is this top one. So x is the same place here as 8. And then this long diagonal line, you guys are going to learn in Unit 3, we call this the hypotenuse, if this is a true right triangle. Okay, and you're going to prove in Unit 3 if this is a right triangle, not by using these three numbers. But I'm going to get ahead of myself. All right, so I have 8. Now I can't use 6 because I use this diagonal line, so we got to use this diagonal line. Okay, 8 over 10. And some of you are trying to reduce this. That's fine. If you reduce it, you can still reduce and then cross multiply. There's nothing wrong with that. So I can go 10x is equal to, and 15 times 8. Let's see what our calculator says. 15 times 8 is 120. I really knew what that was, y'all. I just want to make sure I use my calculator just to be safe, okay? So if I divide by 10, x should give me 12. And there's my side length of DE is 12. Okay? So you see, just take your time with these, and the key is making sure you are pairing up and matching the numbers together. Okay? All right, so that is that part of it, and that's how all we're doing with that. So let's look at, so right now we have figured out how to prove similarity by finding out if it's true or false, and we found out how to do missing side lengths. Now let's look at the indirect measurements. Remember, what we're talking about, indirect measurements are things that we can't measure, like the height of this tree. Well, we can use old Lance the alien here, and we can use Lance's height and his shadow to kind of work this out. And you know, it doesn't matter, you set this up several different ways. But remember, what I like to do is I like to keep these numbers together and these numbers together, as long as I stay consistent. And what I like to do, height over shadow for one side. So this is Lance's height. Lance's shadow is equal to the tree's height. Oops, excuse me, let me fix that. Height over the tree shadow. Well, according to the question, what I don't know is, and this is where it tells me my unknown, what is the height of the tree? I don't know this distance. I don't know the distance from the top of the tree to the ground. So we can do our right triangle, we can set this up. So here we go. Let's do Lance's height. Lance's height over his shadow is equal to the tree's height over its shadow. Okay? So if we cross multiply, we have 5 times 32, I think is 160, but I'm going to use my calculator because it's late in the day and I don't trust myself sometimes. So 5 times 32, excuse me, should be 160. And then if I cross multiply here, I have, and it doesn't matter if you put the 8x over here or here, it doesn't matter, it's the same thing. Okay? Get used to seeing it on both sides, because you will see that at the end of this unit and the rest of the year too. So not 8x, I'm sorry. So we're just going to divide by 8. Divide by 8. So that gives me, what happens here, this goes away. So I have x is equal to 20. And what that 20 tells me is the tree is 20 feet tall or 20 feet high, whatever they say about a tree. Okay, you can use either one, 20 feet tall, 20 feet high. But the key is, can you get me that number right there? Okay? All right. You got a couple of these on your quiz tomorrow. So we're going to do one with a picture and one without a picture. Well, remember, we're going to draw our own pictures when we don't have a picture, okay? So Tasha wants to find the height of the flagpole at the school. So that tells me there's my unknown right there. One morning she determines the flagpole casts a shadow of 12 feet. Well, we know Tasha is 5 feet tall and casts a shadow of 3 feet. So again, I'm going to go height over shadow is equal to height over shadow. So I'm using the pole's height and I'm using Tasha's height. Okay, so height over shadow, okay? So pole height, height over shadow is equal to Tasha's height over her shadow. All right, so you can look right here. Hopefully, maybe we can figure this out. If this is an improper fraction, maybe this will be a bigger number too. Let's just see how that works. All right, so if I cross multiply, 3 times x is 3x. 5 times 12 is 60. All right, so if I divide by 3, I have x should give me 20. And what this tells me is the flagpole, and again, please get used to writing these sentences, but you're going to have to write sentences. I know it's terrible to write sentences in math, but you're going to have to. Excuse me. I do apologize. All right, I apologize for having to step away there for a second. Okay, so what this tells me is that flagpole is 20 foot high, okay, or 20 feet tall. Well, here's the same problem. Now we're going to do it without the picture. Well, we're going to draw our own picture. Okay, so we have the 6 foot tall person. So again, we keep comparing the flagpole to a person, right? So here we're going to draw a little stick person. All right, we know the flagpole is, so we know the person is 6 foot tall, and we know the person is casting a 3 foot shadow. Well, we know the flagpole casts a 5 foot shadow, and here is what the problem is about, right? How tall is that pole? That's my unknown, so we're looking for that height, okay? All right, so ratio, again, height over shadow, height of the pole over the shadow, and the height of the person over the shadow. And again, it doesn't matter. You could have set it up a couple different ways, and you should get the same answer. As long as you are consistent, you could have done height over height equals shadow over shadow. As long as you do it consistently, you could have done shadow over height. As long as you do shadow over height, it's not going to matter, okay? All right, so let's cross multiply here. So we have 3 times x is 3x. 5 times 6 is 30. So if I divide both sides by 3, I have x is equal to 10, okay? So this number tells me exactly what this question asks, okay? The flagpole is 10 feet tall or high, however you want to write it down, okay? But since it used tall, I'm going to try to use tall, okay? So again, set up that ratio, set up the picture, okay? And if you draw that picture, it will help you tremendously, I'm telling you. All right, got 2 more to go, I think, and then I'm going to cut you loose for the afternoon, okay? So just bear with me. All right, we have Alanis is moving, and she needs to pack 2 mirrors. So she has 2 mirrors. We know the larger mirror fits in a box that is 18 inches wide, 20 inches long. So let's draw this big box. And I know it's not straight, so I apologize. So we know we're going to say this is going to be my width, and we're going to say this is length. Well, we know the big box is 18 inches wide, 20 inches long. All right. She has a smaller mirror that is similar in proportion to the larger mirror. She determines that the smaller box, so let's draw a little smaller box. And again, this is width over length. Okay. She determines that the width of the smaller box has to be 9 inches. What she wants to know is how long is the minimum length for that box, okay, before me to put it in. So that is my unknown, the width, okay, I'm sorry, the length. So here we don't have shadows, but we do have width and we have length. So again, it doesn't matter how you set it up as long as you set it up consistently. So I'm just going to set up this proportion since this is my variable. I like to set it up first. So I'm going to go length over width, the length of the small box over the width of the small box. I'm going to go the length of the big box over the width of the little big box. Okay, length over width, length over width. All right, so if I cross multiply, 18 times x is 18x. 9 times 20 is 180. All right, if I divide by 18, I should get x is equal to 10 because these are going to cross out. So what that tells me is the minimum length for the box should be 10 inches. Okay, so you see, just as long as you are consistent, it doesn't matter what factors we're dealing with and what categories we're dealing with. As long as you are consistent with how you set it up, it's not going to matter. All right, here comes some sure enough real world application here. We got blueprints. If any of you plan on being architects, interior designers, builders, whatever, you're going to have to know how to do something like this. Because if you'll notice right off the bat, it says a blueprint for a house is shown below. If the front of the house is 30 feet wide, how tall is the house? Well, the first thing that jumps out to me here is this one is in feet. And if you'll notice, both of these are in inches. Okay, it's not impossible, but I don't like to compare two different units of measurement. So what we're going to do is we're going to do a little conversion after we set this up. Well, if I know inches, right, 1 foot is 12 inches, right? Well, what I'm going to do is I'm going to change this. So if I have 30 feet and there's 12 inches to a foot, I'm going to multiply. I'm going to change this 2 inches. I'm going to get all of my units the same. 30 times 12. All right, that should give me 360 inches. So that 30 foot, so if I draw my other house, I'm going to just kind of draw a little small. It's not going to be the house. It's going to be, we can draw the little house, I guess. Okay, and y'all know my houses don't look pretty. It looks kind of like Willy Wonka in the Chocolate Factory. All right, so this house is 30 feet, but I know it's 360 inches, right? What the question is, how tall is the house? Well, we got a little work to do when we finish. So this one is not going to be as easy to finish up with. We got to do a little work at the end because he wants to know the house, and we're going to measure it in feet. So we got to do a little changing back. We'll kind of give you a foreshadow, okay? All right, so if I set this up, we have the width of the house and the height of the house, and the width of the house and the height of the house. So we're going to set it up width over height or height over width. I don't care, but I like to set this one up first. So the height over the width is equal to the height over the width. All right, so if we cross multiply, we have 12x is equal to, and now this number is too big for me to even do in my head, so I'm going to go down here real quick, and I'm going to move this over here where you can see it. 360 times 14. Okay, so all of this, I'm still cross multiplying, gives me 5,040. 5040. All right, so 5,040. Let's make sure. Yep. Okay, so now I want to solve for that x, so we're going to divide by 12. This is going to go away, so I have x is equal to, let's see what 5,040 divided by 12 is. 420. Now, that doesn't mean the house is 420 feet tall. That means the house is 400 because remember we converted everything to inches, so this is 420 inches tall. So we got one more thing to do before we get finished, before we know exactly what the height of the house is in feet. Okay, because remember this was 30 feet, right? So what I'm going to do is I'm going to take this number, I'm going to do one more division. There's 420 inches, and I know each 12 inches is 1 foot. I'm going to divide 420 by 12, and that should give me the total feet. Divide it by 12 should give me feet, and it does. And what that gives me is x is 35. Okay? So now what this number here tells me, and I know it looks like two different answers, but this is actually in inches and this is in feet. So what this tells me, the house is 35 feet tall. Okay? So again, it doesn't matter, but this is something that for those of you that are going to real world as far as, like I said, drafting, drawing, designing, building, architecture, anything you're going to do with scale, your plans are not going to be drawn 30 feet wide and 35 feet high. It's not going to say that. You're going to have something like 1 inch equals 4 feet. Okay, I didn't use that today, but this is kind of what you're going to see on a blueprint. 1 inch equals 4 feet. 1 inch equals 2 feet. You've got to be able to make these conversions, okay, to find out missing length. Sometimes you're not going to have this total height, okay? So this is very important for what you're going to do in your real life applications. And I hope that these little short videos are helping you figure out how to apply these to your real life. Okay, that's my goal, is to help you figure out how to use this in real life situations. Okay, all right. So please look at this and go back and look at it again if you need to. Remember, your quiz tomorrow is going to be over everything we've done this week: dilations, translations. That's going to be everything that we've talked about since the first of school. So good luck. Please study, and I will see you tomorrow. You guys have a great evening.